Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we are going to conduct lecture number 32, and in this video tutorial we will actually learn about rollover, which happens in timer 0 or in every other timer. So we will discuss this rollover point from timer 0 point of view for the PIC18F microcontroller. So let's start our topic. Okay, we will answer what is rollover in timer 0 or what is rollover point in timer 0. But before we discuss this point, we need to recall some of the facts that we learned in the last tutorial, that timer 0 is actually, uh, it can be operated in two mode. It can be operated in 16-bit mode, or it can be operated in 8-bit mode. So to operate it, we need to count, right? Either we will be counting in 8-bit. That means we will count up to from 00 hex to FF hex, right? This is the count of 8-bit, right? And if we are counting in 16-bit, that means we will be using 4 hexadecimal symbols, right? So that means 0000, and this count will go up to what? Up to F, 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 and F, right? You know that, for example, we will be starting with 0, then we will go 1, it will go to 3, then eventually we will arrive to F, right? Then this counting will start with 1 0 1 1, and eventually we will arrive to 1F. And eventually this counting will go up to FF in 16, sorry, in 8-bit. And if we are discussing uh, 16-bit, then it will go up to 4 times F. You know that these numbers will be stored in some register, so there will be uh, separate separate register will be dedicated for this lower 8 bits, and separate register will be dedicated for this higher 8 bits, right? So those registers are known as timer 0 and timer 0L and timer 0H, right? So basically timer 0L stores the lower byte of timer count, right? And similarly, there is timer 0H register, which is dedicated for higher bytes. So there is another separate register, and this is for what? This is for higher byte of count, of timer count, right? So as I was saying, that these triple F will be stored in timer 0L, and these triple F will be stored in timer 0H. Let me correct it. This is basically cap. So whenever you will be writing registers, these register will be always written in capital. So you do not need to write it in smaller uh, alphabets. Otherwise, it won't be detected in MPLAB, because these are special function registers, and these are deducted as timer 0L and timer 0H. So these are also part of our file register, as these are registers. So these are part of our file register, right? So uh, whenever if you remember, in timer 0 control register, we discussed uh, timer 0 control register, right? We discussed it, and a seventh bit or D7 bit was what? Timer TMR 0 and then on. So seventh bit was timer 0 on bit, and whenever we put one value inside that specific bit, let me draw it for you so that you will understand this point. So this is the timer 0 control register. There are 8 bits from D0 to D7, and we know that D7 bit is basically what? That is timer 0 on bit. So whenever this D7 bit will be equal to 1, then timer will be starting its count, right? Like we know that these two registers will be holding the count, right? So let's let's put some dummy value in these registers and start our timer. So let's see how this counting will proceed. Okay, let's say I'm gonna write move literal to working 00 hertz. Then I'm gonna write move working file timer 0L and move working file timer 0H, right? So what is going to happen? We know that these two registers, timer 0L and timer 0H, right? These two registers will become equal to 00. So let's put these values. Timer 0L would become 00 hertz, and similarly timer 0H would become equal to 00 hertz, right? And what I'm gonna do, I'm gonna start our timer. So how can I start our timer? I have to actually put 1 in this T7 bit, or timer 0 on bit should be 1 in timer 0 control. So how I can do it? I will simply write one instruction that we have already covered. PSF bit set file. We are going to hide the specific bit of any file register. And what file register? Timer 0 control register, comma. What bit? We can simply write 7 bit, because we know that 7th bit is timer 0 on. Or just to make it, just to memorize it, we should practice its name. So timer 0 on, right? Timer 0 on bit will be uh, high, right? So what is going to happen after the execution of this instruction? This T7 would become equal to 1 in this timer 0 control register, and timer will start counting. You know that as I explained you earlier, it will be starting count from 00 hertz, since both of these registers are 00, and it will eventually rise its value 01, 02, 03, and eventually it will arrive to this point. So when uh, timer will be arriving this point, right? So what will be its value? Its value will be updated. Let's say, let me write those value. Those value will become timer 0L would have become FF, and timer 0H would have become FF, right? So that is the last possible value that can actually occur in these two registers. And when this happens, what will be happening after this value? Because timer has arrived to the maximum value of its own, right? There won't be any other increment. If you're going to increment it, what is going to happen? This triple F would become again 4 times 0. Sorry, this 4 times F would become again 4 times 0. So we will be switching back to this value, right? And this point is known as rollover point. When timer actually arrive to its maximum value, which is 4 times f, right, in a 16-bit, right? And whenever this value occurs, and there will be an increment, timer will be counting. So when this thing happens, it will eventually convert into 4 times zeros. So this point, this converting point from 4 times f's to 4 times 0, this point is known as rollover, right? This point is known as rollover point. Let me uh, draw an arrow so that you know what is rollover. Rollover means 4 times f is being converting into 4 times 0. This is called rollover point, right? And furthermore, let's say if we are operating in only 8-bit, that means we will be utilizing only timer 0L register. We won't be using timer 0H. So what is going to happen in that scenario? The 00 hertz will eventually arrive to its maximum value, that is double F. And after the incrementing of this value, what is going to happen? This double F will convert back into 00. This point will call, or this point will known as rollover in 8-bit mode, right? So what is going to happen when this rollover happens? There is one more register which is known as uh, interrupt control, right? Another register which whose name is what? Interrupt control register, right? Or simply interrupt control, right? And that register has again 8 bits, right? So there could be many bits. We won't be actually discussing all the register right now, but you know that this is basically PIC18F microcontroller, and it will have from D naught there will be D1, there will be D2, up to what? Up to D7, because there will be 7 bits. So their D2 bit or third bit is basically of our importance right now. Right now, we will be using this bit. So D2 is known as what it called. Let me write it for you. Timer0IF. This is known as what? Timer0IF. So this bit is basically we will be using, and how we will be using. What is the significance of this Timer0IF bit? First of all, let me repeat myself. When this rollover happens, either we are using in 8-bit mode. In 8-bit mode, what is going to happen in rollover? Double F will be converting into 00, or if we are using 16 bits, so 4 times F will be converting into 4 times 0. So when these points happen, either we are performing it in 8-bit or in 16-bit, this bit Timer0IF. And what is this? Where is this bit? This bit is actually present in interrupt control register. So there is another register which is known as interrupt control register, and this and it's D2 bit, or second D0, D1, D2. So its third bit is basically known as Timer0IF. So whenever this rollover happens, this Timer0IF will become from 0 to 1. So actually it will send a notification, or it will show, it will detect that your timer has actually arrived to its maximum value and rollover points has occurred. That is why this value has become from 0 to 1, right? So this register, this bit is very important, and since this bit is important, so this register is also important. So we this bit will actually let us know how when our timer is expiring. So after starting our timer, how did we start our timer? Remember, we set BSF timer 0 control, comma timer 0 on. So we set this bit of this register equal to 1, and timer was started, right? From 00 hertz to whatever its maximum value. If it is 8-bit, so it would be double F, and if it is 16-bit, it would become 4 times F, right? So when this rollover happens, then this specific bit, and what is that bit? It is Timer0IF. Of what register? Of interrupt control, or INTCON, interrupt control. This register name is what? Interrupt control. That is why it is acronymed INTCON. So this registers this bit. Which bit? Timer0IF would become from 0 to 1, and it will let us know that okay, your timer has arrived to its maximum value, or timer has expired, or timer has actually complete its count. So we will be actually checking this bit, right? And how you can test any single bit of any file register. If you remember, we have covered instruction git test file skip if set, right? Because we're gonna check uh, if that base is high or not, right? So what is the register name, or what is the file name? Interrupt control. And what is the bit number? Either you can simply write D2, or just to memorize it, we will write its name Timer0IF, right? Remember, it is not O, it is 0. Timer0IF. So we will be checking this bit. If that bit has become 1, that means our timer has complete its count, whatever the count we wanted to let it be counted, right? So we will check this particular bit consecutively. And you know that if we want to stay on this line, how you can stay on this line? You can simply write over here what branch ABC, and ABC will be defined before this line. So what is going to happen? Unless this specific bit is becomes 1, we won't be coming out of this loop. We will be again and again checking it unless it becomes high. So whenever this rollover happens, this Timer0IF will become from 0 to 1, right? So this IF will be 1. So this condition would be true, and we will skip this branch condition and we will come out of the loop. I hope this point is clear. So this is very important because it is a way to check whether our timer has complete its count or not. And remember, in this lecture, we have discussed several important registers like timer 0L, which is the lower byte of timer 0 count, right? Timer 0H, which is the higher byte of timer 0 count. Timer 0H will be used whenever we will be using it in 16-bit mode. In last lecture, we covered timer 0 control register. So D7 bit of timer 0 control will be very useful because we will make it one or turn it on using this command BSF, right? So that timer starts its count, and we will be checking this specific bit timer 0 IF, right? Timer 0 IF, initially it should be 0. So remember, I can simply write one more instruction to make it 0 uh, in advance, right? But if you are just restarting this programming, so it will be 0, right? And we will check this instruction. We will check this particular bit using this instruction bit test file, using this interrupt control register. And which bit we will checking? We will be checking its D2 bit or timer 0 IF bit. I hope this point is clear in your minds. If you have any confusion regarding rollover point or regarding any of these registers, you can post your confusions and queries in comment section. Okay, that's it from this lecture. Thank you so much for listening.